Greetings everyone. I welcome you all for a brief video presentation on the topic Quadrant Systems. Computer-aided engineering drawing, also known as engineering graphics, is the subject which will be presented through the presentation. Let me introduce you to myself. I am Bharath M, belonging to Audi section, second semester, Sri Venkateswara College of Engineering, Department of Computer Science Engineering and Artificial Intelligence. The subject I'm presenting to you through this presentation and the video is computer-aided engineering drawing, and the topic would be on the quadrant systems. Let me introduce you what is a quadrant system, and I welcome you all to the presentation on this topic. In this session or in this presentation, we'll explore the concept of quadrant systems, their role in geometry and mathematics, and their practical applications, which is the engineering graphics or the engineering drawing. What are the basics of quadrant systems? Quadrant system is a very complex topic, and to understand this, let's break it into smaller parts and let's go to its basics. Quadrant systems are a fundamental geometric concept that divides the Cartesian coordinate plane into four sections or quadrants. These quadrants are labeled as 1, 2, 3, and 4, or the first, second, third, and fourth, and they help us identify the position and direction of points on the plane. Where is a point located on a given plane? This can be uh, found, found by the quadrant systems or by the numbering or the coordinate system. Let us understand what a quadrant is. Let's dive into the four quadrants. Quadrant 1 is characterized by positive values for both x and y. In quadrant 2, x is negative while y is positive. Quadrant 3 features negative values for both x and y. And finally, quadrant 4 has positive x and negative y values. This is about the four quadrants and the sign convention, or for all the four quadrants, which is a positive and negative. Now let us look at the first quadrant. Let's go through all the four quadrants one by one. The first quadrant, in quadrant 1, both x and y values are positive. This quadrant includes points in the upper right hand portion of the coordinate plane. It's where angles are measured in a counterclockwise direction from the positive x-axis. The positive x-axis on the right side. From there, in a counterclockwise direction, the angle with respect to origin is measured. And here, as we saw, both the values are positive. This is about the first quadrant. Moving on to the second quadrant, quadrant 2 encompasses points where x is negative and y is positive. Angles in this quadrant are measured in a clockwise direction from the positive x-axis. It's often used in trigonometry to find values of angles that are greater than 90 degrees. Now moving on to the third quadrant. Quadrant 3 houses points with negative x and y values. Angles in this quadrant are measured in a clockwise direction from the positive x-axis, but they're less than minus 90 degrees. Quadrant 3 plays a crucial role in understanding the negative angles, as this is where the angles turn negative when it is coming through the anti-clockwise direction from the positive x-axis, which is from the first quadrant. Then the last one is the fourth quadrant. Quadrant 4, they contain points with positive x and negative y values. Angles in this quadrant are measured in a counterclockwise direction from the positive x-axis, but they're less than 180 degrees. Quadrant 4 is valuable for understanding angles between 90 and 180 degrees. Now let us look at the applications of quadrant system in trigonometry. Quadrant systems find extensive use in trigonometry where they determine the signs of trigonometric ratios. The quadrant in which an angle resides dictates whether sine, cosine, or tangent values are positive or negative, aiding in accurate calculations. Let us go to the next slide, graphing equations in quadrant system. When graphing equations, quadrant system help us place points on the plane based on the signs of their coordinates. The position of points in different quadrants assist in creating accurate graphs that visualize mathematical relationships. In the next slide, complex numbers in quadrant system. Quadrant system also play a role in representing complex number. The position of a complex number in a quadrant can help us quickly determine its real and imaginary parts, aiding in arithmetic and analysis. The next slide is about the practical example. In real-world scenarios, quadrant systems are applied in navigation, engineering, and physics. They assist in understanding positions, directions, and angles, making them essential tools for various applications. These are the practical examples where the quadrant system is used in day-to-day life. What are, if there's any application, there has to be some disadvantages or also known as limitations, and there will be some scope for improvement which comes in the form of challenges. While quadrant systems are powerful tools, they may not provide a complete solution in every situation. Challenges arise when dealing with polar coordinate or angles that extend beyond the defined quadrants. Their angles above 360 degree. They get stuck with these quadrant systems. This is a limitation of the quadrant system and a challenge which has some scope for improvement in the future. What is the importance of the quadrant system? Quadrant systems are vital for both teaching and learning geometry. They offer a clear and visual framework for comprehending angles, directions, and relationships between points in the Cartesian plane. This is the importance of quadrant systems. And let us compare this with other coordinate system. What is something special in the quadrant system as compared to the other coordinate systems? Quadrant systems have unique features when compared to other coordinate systems like polar or spherical coordinates. They excel in straightforwardly conveying directional information, and they are particularly handy for understanding angles. That is, it is very easy to understand as compared to the other coordinate systems which are defined by other mathematicians. And in conclusion, quadrant systems are foundational to geometry and mathematics. The division of the coordinate plane into four distinct sections facilitates clear communication of positions, directions, and angles. Thank you all, and I appreciate your time and engagement during this presentation. Feel free to continue your exploration of quadrant system and their significance in mathematics and beyond, that is, towards engineering. Thank you, one and all, for being a part of this video. Thank you.